We're very fortunate today to have with us Professor Thomas Neeson. Professor Neeson is an associate professor in geography and environmental sustainability here at OU. He and his students work on water sustainability with a focus on rivers and freshwater systems in the Great Plains in south central United States. Can't think of a more important topic. Professor Neeson, in addition to earning a Bachelor of Science and a Master of Science at Case Western University in Cleveland, Ohio, also has a Master's in Statistics from the University of Michigan, and earned his doctorate in Natural Resources and Environmental Sustainability at the University of Michigan. And he is, we met a few years ago now, and it finally has worked out for Professor Neeson to come and speak to us. He runs a lab here at OU. He has mentored so many students. It's really quite impressive. Publishes and reviews articles at a great rate, and has raised no small amount of money for his lab. And if you're interested in what a water scientist does, I really encourage you to visit his website, as I have done, Neeson, Neeson, and check him out, and check out what he's accomplished here at the University of Oklahoma. Very impressive. I asked Professor Neeson, not only because he's a colleague here at OU, and because, like a lot of us, we've thought for a long time that water is likely to be the key resource of the 21st century that needs maintenance and sustainability, but also because I found out in passing that he spent 2 years as a postdoc at Hebrew University, and has an extensive knowledge of Israel's water sustainability programs and how that might be helpful, applicable for our own very real needs. And so, without further ado, let me introduce Professor Tom Neeson, and thank you very much for participating today.
Hi, everyone. Thank you for coming. Alan, thank you for that very kind introduction. Alan and Trice, thanks for inviting me. So as Alan mentioned, this talk was a lot of fun for me to put together. I came to OU in 2015, and before that was a postdoc at the University of Wisconsin. So I've been in the US for about a decade. But before that, I was a postdoc for 2 years at Israel, and so I have a lot of interests in water sustainability issues in Israel. Most of my work focuses here in the U.S. and in the South Central U.S., but putting this talk together was a lot of fun and a chance for me to think about Israeli water sustainability issues again. So a lot of the ideas in this talk are drawn from a few sources. Some of you may be familiar with Seth Siegel's book, Let There Be Water. Got a little bit of press maybe 5 or 8 years ago. I drew quite a bit from Alan Tall's Pollution in a Promised Land. It's an environmental history of Israel. And then a number of journal articles inform this talk as well. So Israel is I think many people recognize Israel as a leader in water sustainability in several ways. And so Israel's national water strategy rests on a few pillars. It's primarily a strategy of increasing supply rather than reducing demand. And the strategies for expanding supply are kind of integrated at the national level. So they have integrated management of Lake Kinneret and the groundwater aquifers. They have a pretty extensive system of water harvesting via rain-fed reservoirs. They have a tremendous amount of wastewater reuse, mostly for irrigation. And they are also a leader in desalination for increasing fresh water. They also work to reduce demand, kind of most famously through innovations in drip irrigation, and some smaller things like residential water use behavior and dual flush toilets that are kind of small individually, but in aggregate reduce demand quite a bit. So in this talk, I'm going to focus mostly on wastewater treatment and wastewater reuse. And the reason I'm going to focus on that is because it's a big topic here and something that we care quite a bit about in the south central US. So what is wastewater reuse? Basically, when we have wastewater, whether that's from sinks or toilets or anything else, it's treated, so it's collected at a wastewater treatment plant. And then for the most part, we discharge that treated water back into water bodies or other places. Wastewater reuse is just what it sounds like. Instead of discharging that wastewater, maybe we could take it and use it for some other applications. And there's a number here on the left. Most commonly, it's used for irrigation. But we can think about a few categories of reuse. So we can think that wastewater might be reused for non-potable uses, irrigation, cooling, and other industrial uses. This is by far the most common. In some cases, we might think about indirect potable reuse. So we're going to take this wastewater, clean it in some way. Indirect here means that it's first going to be buffered through some kind of natural water body, like a lake or a river, and then maybe it's suitable for drinking water. And then in rare cases, maybe we can directly use treated wastewater for drinking water without an environmental buffer. And so Israel is by far the world's leader in wastewater recycling. Depending on which source you look at, the numbers vary a little bit, but Israel reuses between something like 80 and 90% of their wastewater. Some of the kind of other countries that are leaders are quite a bit far behind them. Spain, Australia, the US is not on this figure. We're somewhere in the 3 to 5% region. And Israel accomplished this through pretty massive investments in infrastructure. So this figure on the left here is a figure showing the national water carrier. So Israel has a nationwide infrastructure for transporting water. Integrated into that national infrastructure are things like on the figure on the top right there. This is the Dan region wastewater plant, also called Shafdan. So this is a massive wastewater plant that collects all of the sewage for Tel Aviv and some of the neighboring municipalities. That wastewater is cleaned and then piped south, and wastewater from that treatment plant provides a little over 60% of the irrigation water in the Negev. And we've also, in addition to these large facilities, we've got a kind of a number of smaller facilities. On the bottom here, we're looking at a reservoir in the Negev that's pretty small scale, but these are dotted around the landscape too. So overall, we've got a tremendous amount of water infrastructure in Israel that serves to kind of collect this wastewater, move it around the country, and make it available for different uses. And so this is interesting to us in the U.S. because in the U.S. we have really a pretty big gap between our wastewater production and our wastewater reuse. And so this is from a global synthesis that came out last year thinking about wastewater production in Figure A. And so you can see that the U.S. is dark red. We produce a lot of wastewater here. And if you look on the bottom right on Figure D, these numbers are a little bit different. They're calculated a little bit differently than the slide that I showed a couple slides ago. But the U.S.'s wastewater reuse is kind of somewhere between 2 and 10%, depending on how you calculate it. Right? So we have a lot of opportunities to reuse the wastewater that we're producing in the U.S. And so we are talking about this at the national level. The U.S. EPA has something called a National Water Reuse Action Plan. This just got released in 2020. People in the U.S. first really started talking about wastewater reuse in the 70s, following the passage of the Clean Water Act in 1972. There's a little bit of buzz about this in the 70s, some professional interest, and then it kind of died out for 20 or 30 years. There are a few projects here and there. but it really didn't take off the same way that it took off in Israel and some other countries. And so this national plan lays out some strategies for how we might boost wastewater reuse nationally. The little bit that gets done in the US is concentrated in just a few places. So California, Arizona, Texas, and Florida do about 90% of the wastewater reuse. And it really varies state by state. So there are no federal guidelines for how we should do this or issue permits for this. And it's mostly up to each state to set their own priorities. Okay. And so here in Oklahoma, we do a little bit. We have been permitting these wastewater reuse projects since the 90s. I'll talk a little bit about some of the projects that we do have here in Oklahoma. But I think the vision is that we're going to be doing more of this in the future. So in 2012, Oklahoma passed something called the Water for 2060 Act, and it's basically a statewide water plan. It set the pretty ambitious goal of using no more fresh water in 2060 than we're using in 2012. And they proposed, so to achieve that water goal, they proposed a number of strategies. Wastewater reuse is one of them. So this statewide water plan says that wastewater reuse can be a really important part of our portfolio of strategies for increasing water sustainability. Okay? Apologize for squinting here. So on the right here, we're looking at basically a fact sheet that comes out of this planning document. And it says here, public water suppliers are encouraged to consider treated effluent reuse where it is both cost-effective and supported by the public, right? So we've got two things to think about. Is this going to be cost-effective, and do we have public support for wastewater reuse? And then they also, maybe of interest to folks in the room, they also talk about a couple of cases where this is happening already in Oklahoma. And here within Norman, we do a little bit of wastewater reuse. The OU's golf course is irrigated with wastewater, and so it's basically offset some of our drinking water demands if you can, rather than pooling that irrigation water from the potable water supply, we can reuse wastewater. Okay. And so what I wanted to think through with this talk was kind of, if we think about Israel as a global leader in wastewater reuse, to try to ask whether Israel might have some lessons for the South Central US about ways that we might do wastewater reuse, or whether these places are too different and there are not too many things that can translate here. And so I wanted to focus on a couple things. I wanted to ask or kind of think about what are the ecological costs and benefits of wastewater reuse. I wanted to think a little bit about whether we've got public acceptance for wastewater reuse. And then also, I think there are really interesting kind of spatial planning problems here. And so if we think toward the future, we have some idea, but a little bit of uncertainty as well about what future climate might look like and what future water needs might look like. And so I think there are some interesting spatial planning problems about how we want to make investments in water sustainability infrastructure if we're not sure when and where it might be needed. Okay, so let me talk a little bit about Israel. I think maybe one case study is to think about the Yarkon River, which is just north of Tel Aviv. And so in 1997, kind of famously, a pedestrian bridge over that river collapsed during the opening ceremonies for the Maccabiah Games. 4 athletes died due to exposure to the polluted river water, and a number of other athletes were hospitalized. And so the river was quite polluted. Today, that river is still polluted, but and it's a central feature of the Yarkon Park just north of Tel Aviv. So this is really a very nice urban park. It's about 16 million visitors annually. And again, the river is far from pristine, but it has really improved in condition over the last some years. And so the history of this river is pretty interesting. So this is a picture of Rosh Hashanah Spring, taken in 1932. These are the headwaters of the Yarkon River, and so you can see it's a for Israel pretty sizable river there. This river at the time served during the Mandate period. This was part of the water supply for Jerusalem, so they would pump water to Jerusalem But for the most part, this river flowed down into the Mediterranean uninterrupted. Okay? Since that time, it has been heavily modified and engineered and regulated in a number of ways. So the first water carrier, so part of what became the national water carrier, tapped the Rosh Ha'ayin Springs, so kind of just on the bottom right of this map here, and took the large majority of that water south to the Negev for irrigation. These are, at the time, these were the largest water carrying pipes in the world, 66 inches. So you're just taking a massive amount of water out of this system and sending it southward. And so basically downstream of that diversion point, the Yarkon River that was left behind was, quote, a putrid trickle of raw sewage and effluents. And so this river was in bad shape. And so just to orient you on the map here, here's Tel Aviv. So the river is just north of Tel Aviv. And today we have a number of wastewater treatment plants and some parks here that I'll talk about in a second. Okay, so today, so prior to that diversion, the Yarkon was a perennial stream, meaning that it flowed year-round out to the Mediterranean. Now, with that base flow being piped south, the discharge in the river really relies on the wastewater effluent that comes out of those wastewater treatment plants. And so the river is, again, a perennial stream. Like, there's water flowing out to the Mediterranean year-round, and it's a pretty sizable flow. But a big, I believe the large majority of that flow is wastewater discharge from the wastewater treatment plants. And so there are a couple things that are interesting here. So if we didn't have that wastewater effluent, this stream would not be flowing. And secondly, the quality of that effluent determines the health of the river. And so if that effluent is clean, this could be potentially a pretty healthy system in terms of the water inputs that go in there. And so in that kind of last few decades between the bridge collapse disaster and what is today a healthier system, there have been a number of investments in rehabilitating this river. There has been some water reallocation, so we're kind of they have changed the way that they're sending some water south and other water being discharged from the wastewater treatment plants. There has been some upgrading of those wastewater treatment plants so that the effluent is higher quality. And there's been some constructed wetlands, so we have some natural areas that kind of serve to clean this water and increase the water quality. And so this history of the Yarkon is in a way, a history of the way that rivers in Israel can be engineered and regulated for different uses. And so this diagram on the left is showing kind of a history of what many rivers go through. We start off with this original situation where you have an unregulated, clean river flowing into the sea. Stage 2 is maybe a conventional sewage treatment operation where you're taking some water out of that river. It's a drinking water source for a city. It goes through a wastewater treatment plant, and then it's discharged into the river. If that treatment is done poorly, then you've got a polluted river, and this was historically the case. We can do a one-step wastewater reuse, and so rather than discharging that sewage to the dry river, we could clean it and use it for irrigation. So kind of phase 3 there is a good thing because we're increasing water availability for agriculture, but we are potentially not doing such a great job at keeping water in the river and thinking about the ecosystem services and benefits that we might get from a flowing river. And stage 4 is something a little bit more creative, and maybe this is where the Yarkon is right now, where we're doing a lot of engineering and moving around of water. The water gets taken out, used for a municipal water supply, we treat it, we might put it back in the river, it can flow in that river for a while, maybe somewhere else we take it out for irrigation. And so there's just a lot of moving of water around. And if you do this well, you both meet your municipal and societal water plans, you get water for irrigation, and you keep some water in the river. Okay? I think this is done or proposed for a number of rivers in Israel. A lot of these reports are in Hebrew, and so it's tough to kind of get the details about what's going on. But there's a number of things in the work here. Okay? And so I think it's interesting to think about whether this might be a model for the U.S. or does this happen in the U.S. And actually, one of the examples is pretty close to home for us. So this is the Trinity River in Texas. The Trinity River flows through the Dallas-Fort Worth area and flows all the way down to the Gulf of Mexico. The section we're interested in ends in Lake Livingston. So this is a stretch of a little over 300 kilometers. And this river is heavily reliant on wastewater discharge from the Dallas-Fort Worth area. And so this is a case where this is done pretty well. In the sense that prior to urban development, the Trinity River was an ephemeral stream. It would dry up in the summer, like many rivers in arid or semi-arid climates. Nowadays, the base flow is sustained year-round by wastewater discharges from Dallas-Fort Worth. And since the 70s, we have tremendous improvements in water quality and habitat. And so this was partly because we've got more water in the system, but also partly due to some improvements in water quality that came along with the Clean Water Act in the early 70s. And so this is a case where wastewater effluents are really an important part of a river rehabilitation strategy. And so, for example, we went from 4 fish species in this river in the early 70s up to 25 fish species in the 90s. So wastewater discharges to rivers can be an ecological benefit. They can improve the health of rivers. But it's tricky to think about kind of impacts for using this wastewater for irrigation as well. So this is an example of a hydrograph from a river in Oklahoma. And what we're looking at here, the blue line is just the amount of water in the river over time. And so in places where that line peaks up, we're at a flood stage. In places where this blue line gets quite close to zero, that river is dry or almost dry. The orange bars are showing us the percentage of that flow that is wastewater. And so basically what happens in a lot of these systems is you have wastewater discharge from a treatment plant that's more or less constant year-round. There's a little bit of fluctuation, but it's mostly constant year-round. And so if you're thinking about a river, in places when you have a lot of natural a lot of flow naturally in that river, the wastewater is a small fraction of the water in that system. During drought periods, like instances when this blue line gets pretty close to zero, the wastewater makes up a huge fraction of the water in that system. And so if we're maybe thinking about some alternative strategy where we're going to take the wastewater and reuse it for irrigation, we might be looking at places where rivers that used to have water in them now dry completely once you take away that wastewater. And so I'm part of a project with some folks here at OU trying to think through the kind of implications for wastewater reuse here in Oklahoma. And so what's outlined in our state here, this is the Red River Basin, or kind of the Oklahoma half of the Red River Basin. This is the Red River itself is the border between Oklahoma and Texas. And each of the little red symbols on this map is a municipal wastewater discharge. Okay? So we have we're trying to think through if we were to take the wastewater discharges from these different cities, rather than putting them into rivers, we used some of them for irrigation or indirect non-potable use. This is an interesting spatial planning problem because we can probably find some places within the basin where we're going to be in something like the bottom right of this figure. So there are probably some places in the basin where wastewater reuse is going to give us high social benefits, right? So we have a chance to increase water availability for human uses. Hopefully with minimal impacts on the river ecosystems and the benefits that we get from river ecosystems. There might be some other places where we're, like somewhere in the top left, for example, where wastewater reuse is not going to give us so much of an increase in water availability for human uses, and may potentially have some big impacts on river ecosystems. So this project is in the early stages, but we're just starting to think through kind of some of the costs and benefits of wastewater reuse projects, and how we choose these, how we choose where we might do them across the basin. I mentioned a little bit about public support for wastewater projects. I think it is, there are cases where proposed wastewater projects don't take off, don't get off the ground. And that can occasionally happen due to lack of public support or public opposition to these projects. So here's an example. This is in Florida. We are looking at a reservoir that is the main water supply for the city of Tampa. There was a proposed project where they were going to take some water out of that reservoir to increase potable water for the city of Tampa. And then downstream of that water, they were going to augment the river flow with reclaimed water, so treated wastewater. This project never got off the ground due to concerns about trace levels of pharmaceuticals in the effluent. This is a problem nationally in many places. And more generally, some impacts or concerns about impacts of the treated wastewater on river and human health. And so one thing we might ask is, given how extensively Israel does wastewater reuse, are Israelis more supportive of reuse projects than the U.S.? And so this is a table that's kind of summarizing survey data about people's willingness to use recycled water in different countries. And so if you look in this first column, for example, this is asking about people's willingness to reuse recycled water for watering their plants, for example, for landscape irrigation. And so Israel is quite high. That's about 95% of the people in Israel said they'd be willing to do that. But it's not too far off the US, right? So people in LA, 93% of them said they'd be willing to do that. And so support for this is high in Israel, but not all that different from public support for this in the US and other places. There's also some evidence that relatively simple public outreach programs can do a lot to increase support for wastewater reuse. So this is a paper. This is from a paper published by Madeline Wade, who is an undergraduate here, graduated a couple of years ago. She's starting a PhD here in the fall. But she looked at people's willingness to use recycled water. Here in Norman, actually, we have a candidate indirect potable reuse project. And so the figure on the right, the green is before the public outreach. She asked people about their willingness to use recycled water for different uses. And then they had a pretty simple public outreach program where they basically showed them in a little jar. They said, this is what recycled water looks like. It doesn't look all that different from the water that you get from a regular municipal supply. And once you do these pretty simple outreach interventions, people say, oh yeah, I guess I am willing to use recycled water. And their willingness to use this shoots up quite a bit. One of the last things we're curious about is thinking about how water supply and demand might change in the future. And so this is something that many places are wrestling with. And so these are some models from Israel looking at future climate scenarios. And so the numbers change depending on which climate scenario you're looking at. But many of them suggest it's going to get quite a bit warmer. And that figure on the right is looking at projected changes in first precipitation and then water demand, and then water availability is the final bar. So we're looking at a future in which precipitation likely goes down and water demand likely goes up, and water availability likely goes down quite a bit. And so we will likely need, and it's the same in the US. So if you look at projections of water availability under future climate scenarios, things are going to change, and we are likely going to have less water in the future. But there's a lot of variability across future climate scenarios. And so these images, we're looking at the outline of the Red River Basin here. So the state of Oklahoma is basically the northern half of this basin. And the 9 figures that we're looking at are basically, each row is showing us a different emission scenario. So the top row is showing us RCP 2.6, it's a low emission scenario. And so this is basically if we cut back on greenhouse gas emissions. And RCP 8.5 is a less, a higher emission scenario. So we're thinking we're going to have more greenhouse gases in the future. And then the columns are showing us 3 different climate models. So there are hundreds of climate models out there. They all give us slightly different projections for the future. And so here we're looking at combinations of 3 different climate models and 3 different scenarios. And so the figures are showing us how runoff, surface runoff of water might change across the future. But places where it's red or brown, we're going to have less runoff in the future. And so you can see there's a lot of variability across climate scenarios, and within each climate scenario, there's a lot of spatial variability. And so even if we can say, on average, things are likely to get drier, this is an interesting spatial planning problem if we think about where we want to put water infrastructure, because we don't really know where we're going to have the greatest need for it. And the same goes for thinking through the impacts of these different future climate scenarios on fish species and the other organisms that live in rivers. And so this is some work that a former master's student did. What we're looking at in these figures are projected changes in the distribution of fish species. So each line in this figure is a different fish species. And basically the width of the bars tell you how uncertain we are about what's going to happen to that species in the future. And so there are some species where that bar is small, and it's close to 0. So we can maybe have some confidence that at least due to climate, we don't expect too much change in the distribution of that species. There's some where it's massive, right? And so if you look across those future climate scenarios, there are some species where they might expand their range by 20%, or they might decrease their range by 30%. That's a tremendous difference if we want to be proactive about conserving these species. Okay. And so a lot of the work that my students and colleagues work on is thinking about this spatial planning problem of how and where should we put water infrastructure if we're uncertain about what the future will look like. And so basically, we take a lot of spatial data sets about water rights and historical water usage, and we take some hydrologic data and models, so computer models that tell us how the water is moving around the system, and we take some biological data that let us make some predictions or projections about where species will be in the future. And we put these all into some computer models that let us try to make some guesses about where would be good places to build water infrastructure. And one of the things, so a couple things come out of these models. One is we can try to think through what are the trade-offs between meeting our societal water needs and keeping all of the water that we need in the system for environmental benefits. And so we can kind of trace out that trade-off curve and think about where we want to be on that trade-off curve. And we can also think about kind of how small changes in water consumption might ameliorate these trade-offs. And so these models suggest that even pretty small changes in water consumption, so something like 3 to 5% reduction in water use, can have a big impact on letting us fully meet both our human water needs and our environmental water needs. But the trick is you've got to be really careful with where you make those investments in water savings in space and time. Okay. And so I mentioned kind of variability across future climate scenarios. A former postdoc in my lab was interested in this question of looking across the Red River Basin and trying to decide where should we make some investments in water infrastructure projects. Okay? And so what we're looking at, this is an outline of the Red River Basin. Each little square here is showing us across future climate scenarios, how consistently do we run out of, are we low on water in that reservoir? And so the reservoirs that are outlined in blue are ones that are never water scarce. So if we look across the future climate scenarios, we never see a shortage in water in those reservoirs. The reservoirs in red are always water scarce. So if we look across those future climate scenarios, we are pretty certain that we're going to be running low on water in these places. And then the reservoirs that are in yellow are the tricky ones, because there are some future scenarios where we're low on water in those places, and other future scenarios where we're not low on water. And so those yellow places are tricky to plan for if you want to make an investment, right? So wastewater reuse projects, they require an investment in permitting and infrastructure, and there's a cost to investing assets into building these projects. And so one way we might think about that is trying to think about kind of future locations, kind of measuring the future water scarcity for those locations. So the horizontal axis here is just how scarce do we think water might be at that place in the future? And then also for that place, thinking about our uncertainty about future conditions there. So the vertical axis just tells us how uncertain are we about that water availability. And so there are places where you've got low water scarcity and low uncertainty. We might think about that as a secure water resource, right? We've got enough water, and we're pretty sure that we'll have enough water in the future. Places in red, those are places where we're projecting that we'll have water scarcity in the future, and also we have low uncertainty about that. So we might be comfortable making some investments in water infrastructure or water strategies there. And then the places in the yellow are where it gets a little bit tricky, right? So those are places where in some future scenarios we might have high water scarcity, but in other future scenarios things might be fine. And so it's tricky to think about making a big investment in some kind of infrastructure or permitting that potentially becomes a sunk cost if it turns out that we've got plenty of water in the future. So I hope that was some food for thought, and I think Israel is a really interesting case to think about here. So it's a country that has had a lot of success with water efficiency and water sustainability. They've achieved that through wastewater reuse and a lot of other creative strategies. I think in that sense they can be a good model for what we might do here regionally. But there are also a lot of things that Israel does that are tricky, right? We will never have probably not a national water carrier that kind of owns all of the water rights for the U.S. and kind of makes high-level decisions about where that water goes, right? There are a lot of key differences that kind of make the Israeli model difficult to implement here. But a lot of the things that they've done are really neat models for how you might kind of have these systems where you move water around among municipal uses and wastewater and irrigation and all these other things. There are a lot of interesting questions related to kind of public acceptance and permitting and water rights. I didn't talk about water rights at all, but there are some really interesting questions related to water rights, I think. And I think a lot of questions, both in Israel and here and globally, about how we plan for water sustainability, given a lot of uncertainty about what the future is going to look like. So thank you, everyone. Thank you again to Alan and Trice for inviting me. I hope that was. I'd be happy to take questions. Thank you. Yeah. Yeah.
Or just thinking anecdotally, Israelis seem to not do things with water that Oklahomans do. Namely, they don't seem to water their lawns as much, and they don't seem to water their cars as much. Are there personal water behavior things we could copy from Israel that would be helpful?
Yeah, so in both places and globally, agriculture is by far the biggest user of water. And so, yeah, those individual behaviors can make a difference, but they're a relatively small difference compared to big industrial users and ag users. Yep. Yep.
wondered for at least a decade or two why America doesn't have a national water carrier, or at least a regional water carrier. It seems to me that every year you read about the Mississippi and the Missouri flooding over, and every year some area of the Southwest, and often on this side of the Rockies, is desperate for water. I don't understand what the impediments are.
That's a great question for political scientists. I don't know. My sense is that's I don't know. Yeah.
But technologically, you could do it, right? If you can bring oil from Canada to Houston, surely you can bring the water from the Mississippi to Oklahoma.
I think those are I think there are a number of political and economic right. You could do it. I don't know whether it's cost effective to do it, and the politics of that involved. That's a really interesting question. I'm sorry to punt on that answer, but yep.
Excuse me. I grew up in South Central Oklahoma, so I am interested very much in that area. And I wonder, have you already thought about how you will bring public awareness and gain support in those, say, little towns down there, and if you anticipate apathy or resistance, and how would you address that if you're that far along?
Yeah, that's a great question. I think so one model for how that might be done is through something like an extension service that Oklahoma State has, right? And so that's specifically agriculture focused, but you have people whose expertise and job is to kind of connect with growers and landowners in the area. I know the South Central Climate Adaptation Science Center here on campus is I think still in the process of hiring someone who's they can't call it an extension person, but someone who has a similar expertise. And so it's someone who's going to have some expertise in working with communities and thinking about climate impacts and climate adaptation strategies, and kind of helping those communities connect with resources and decision making related to those things. I think it's tremendously important, and I think we need more people like that who have some expertise in outreach and building communities. Yep.
On the Water for 2060 Act in Oklahoma, the lead in implementing the requirements of that act, doing the planning, setting up the regulatory strategies.
Yeah. So the Oklahoma Water Resources Board coordinates the water planning, and then there are a number of different agencies that do different things. So we have a Conservation Commission, we have a Department of Environmental Quality, we have a Department of Wildlife Conservation, and so different agencies handled different components of water sustainability or river ecosystems.
How well integrated are they?
I'll punt on that too, right? I think that there are a number of issues where there's a history of good collaboration among agencies, and then I think issues, especially emerging issues, where there's kind of discussion about how we'll move forward with collaboration among different agencies. Sure.
Let me thank Professor Tom Neeson so much for his talk. You said you punted a couple times, but mainly touchdowns and field goals, it seems to me. And I want to wish all my colleagues and students a successful end of semester. Hope you get all your work done, students and colleagues. Hope you get all your grading done. And good luck to everybody. And thank you very much. And let's give Professor Neeson a hand again.